How would you like to have a time machine that could take you back anywhere over the past 300,000 years? You could see what the world was like when ice sheets 1,000 feet thick blanketed Canada and northern Europe, or when the Indonesian volcano Toba blew its top in the largest volcanic eruption of the last 500,000 years. Well, scientists have such a time machine. It is called an ice core. Scientists collect ice cores by driving a hollow tube deep into the miles-thick ice sheets of Antarctica and Greenland and in glaciers elsewhere. The long cylinders of ancient ice that they retrieve provide a dazzlingly detailed record of what was happening in the world over the past several ice ages. That's because each layer of ice in a core corresponds to a single year, or sometimes even a single season, and most everything that fell into the snow that year remains behind, including wind-blown dust, ash, atmospheric gases, even radioactivity. Indeed, fallout from the Chernobyl nuclear accident has turned up in ice cores, as has dust from violent desert storms countless millennia ago. Collectively, these frozen archives give scientists unprecedented views of global climate over the eons. More important, the records allow researchers to predict the impact of significant events, from volcanic eruptions to global warming, that could strike us today. In April 1986, Russia's nuclear power station at Chernobyl exploded, killing 250 people and sending radioactive fallout around the world. Less than 2 years later, as the graphs indicate, scientists detected Chernobyl radioactivity in snow at the South Pole, a graphic reminder of how small our planet is. In cores from Antarctica and Greenland, researchers have pinpointed the beginning of atomic bomb testing in the mid-1950s. They have also identified a spike representing fallout from stepped-up atmospheric testing that took place just prior to the 1963 Test Ban Treaty, which allowed for underground tests only. In the years following 1965, by which time some 90 countries had signed the treaty, Antarctic snow revealed a sharp drop in radioactive fallout. Gases trapped in ice cores show the dramatic impact that human activities have had on the planet since the Industrial Revolution. Atmospheric carbon dioxide, methane, and nitrous oxides from coal and oil burning power plants, cars, and other fossil fuel burning sources have climbed along with the world population, with as yet unknown effects on the climate system. Sulfates, which originate primarily in coal-fired power plants, started rising around 1900. This rise is partially attributed to increased volcanic activity in the Caribbean around the turn of the century. Nitrates didn't begin to climb significantly until after 1950, when cars and oil-powered plants appeared in a big way. Scientists credit the leveling off in sulfates and nitrates in the atmosphere after the 1972 U.S. Clean Air Act went into effect.